When you picture an electric vehicle, there's almost always a very specific image that comes to mind.
Right, usually parked somewhere.
Yeah, exactly. Like you picture a sleek car parked in a driveway, physically tethered by this thick black cable to a box on a garage wall.
Or, maybe you picture a driver sitting in a random parking lot just waiting in line at a massive, permanently fixed public charging station.
Right. We're so conditioned to think of the car having to go to the power. But, what if the power could actually come to you?
Well, it completely flips the century-old paradigm of the gas station. We are, conditioned to believe that fuel is a destination that you have to navigate toward.
Totally.
But when you untether the energy source from the electrical grid, it forces us to rethink the fundamental physics and the economics of how vehicles operate.
Which is exactly what we are unpacking in this deep dive today. The shift toward mobile EV charging and charging as a service, or HECORS as it's known, is aggressively bypassing the traditional power grid.
It really is.
And we've got a fascinating stack of sources for this. We're going to look at corporate financial reports, actual hardware spec sheets, public policy briefs, and strategic pricing guides.
Yeah, the data is pretty incredible.
It is. Our mission here is to figure out how the EV industry is eliminating range anxiety, saving literally millions in infrastructure costs, and just rewriting the rules of how we fuel up. So, okay, let's unpack this.
Let's do it.
To truly grasp the scale of this mobile transition, I think we first have to look at the sheer logistical nightmare of fixed infrastructure.
Oh, absolutely. The bottleneck is real.
Right. I was reviewing the industry data from Drives, and with global EV sales growing by 20% in 2025 alone, the fixed charging network is just bottlenecked by the reality of civil engineering. Why do we even need mobile chargers so badly?
Well, the physical installation is honestly only half the battle. When a major auto dealership or, say, a delivery fleet depot decides to install fixed DC fast chargers, they are initiating a months-long, highly invasive construction project.
Like tear of the parking lot.
Exactly. The Blink charging source material outlines this make-ready infrastructure beautifully. You are literally tearing up concrete to trench for new high-voltage lines.
Oh, wow.
Yeah, and you're completely upgrading the facility's electrical panels, which, often requires waiting on the local utility to install larger transformers just to handle the megawatt-level draw.
So it's not just plugging in a box.
Not at all. All of that requires municipal permitting, which can easily delay a project for the better part of a year before a single charging cable is even purchased.
It's like buying a house just to get a glass of water.
Yeah.
And even if a commercial fleet survives that permitting gauntlet, they instantly slam into utility rate structures.
Yeah, it's a match.
Yeah.
If I'm running a logistics hub and I plug in 20 delivery vans at 5:00 p.m., I am instantly triggering peak demand utility charges. The utility company is billing my business at a massive premium because my sudden power draw puts intense strain on the local grid during high traffic hours. And those demand charges are brutal. They're often based on the highest 15-minute interval of energy use during an entire billing cycle.
Wait, 15 minutes?
Yeah, just a 15-minute window. So a single simultaneous charging session for a fleet can completely destroy a company's profit margin for the whole month.
That is insane. If I own an auto dealership or a delivery fleet, my core competency is selling cars or delivering packages. I want to sell or drive cars, not become an electrical engineering firm,
Which brings us to the charging as a service model, or EGIS. Looking at the Drives report, this entirely removes the operational headache.
How does it actually work in practice?
Basically, a third-party cost provider takes over the entire life cycle. They do the site assessment, they fight with the city for the permits.
Which is a huge relief, I'm sure.
Oh, massive. They coordinate with the utility, and they manage the daily software operations to avoid those peak demand penalties we just talked about.
So the business just outsources the headache.
Exactly. Financially, it's a profound shift for the business owner. The facility no longer owns the charging hardware or absorbs the massive, unpredictable upfront capital expenditure.
They just pay a subscription.
Right. A predictable, recurring monthly subscription fee to the CABS provider. It shifts the burden entirely to operational expenditure, which really de-risks the electrification transition.
Okay, I find it fascinating how CAS removes the financial and operational barriers of fixed infrastructure, but you're still fundamentally bolting hardware to the ground.
You are, yeah.
So if you really want to scale, the next logical step is eliminating the physical barrier itself. This is where the mobile on-demand charging hardware enters the picture.
Which is a game changer.
It really is, because when you sever the cord to the fixed grid, you can directly target the single biggest psychological barrier to EV adoption, which, according to the AAA source in our stack, is still range anxiety.
Oh, without a doubt. And AAA actually has a deep history here.
Right. They were testing this years ago.
Yeah, they piloted a prototype version of mobile rescue charging back in 2010. They ran it for 10 years, retired those original 5 prototype vehicles, and basically used a decade of engineering and consumer behavior learnings to inform their new rollout.
That's a lot of testing data.
It is. Now they're running a massive pilot program across 16 major metro areas, places like Orlando, Denver, San Francisco, sending specialized trucks equipped with mobile EV chargers directly to stranded drivers.
Which is huge for peace of mind. And AAA is integrating this into their digital ecosystem too, with tools like TripTik and TripCanvas, designed to route drivers safely from charger to charger.
Yeah, it's a very holistic approach.
But if a driver still miscalculates, this service acts as the ultimate safety net.
Yeah.
It's almost like the Uber Eats of electricity. You just push a button, and a truck delivers enough raw energy to get your car to a fixed station or just back home.
That's a great way to put it.
But I want to know how this tech actually works on the ground for everyday businesses and fleets, because dispensing high-voltage direct current from the back of a truck has to be an incredibly complex engineering challenge.
Oh, it's a huge challenge. And we have a fascinating showdown in the sources between portable modular systems and larger hybrid systems.
Right, B-charged versus spark-charged.
Exactly. Spark Charger is a perfect example of the ultra-portable philosophy. They produce this thing called the Roadie Portable, which takes a completely modular plug-and-play approach.
Modular how?
Well, instead of housing one giant immovable battery in the back of a van, the Roadie consists of individual battery modules. Each module weighs roughly 70 pounds and holds 3.45 kilowatt hours of energy.
70 pounds.
Yeah.
So the sheer physical footprint is small enough that a single roadside assistance worker can literally pick a module up, walk it over to a stranded vehicle on a busy highway shoulder, and just stack it.
Exactly. The modularity is the key to its scalability. A technician can stack up to 4 of these 70-pound batteries together right there on the spot.
And they don't short out.
No, the system uses parallel connections and an integrated battery management system to link the module safely. Once it's connected to a charging head, it can deliver up to 60 miles of range at a speed of about 1 mile per minute.
Wow, that's fast.
And it bypasses the need for installation entirely.
That modular approach is brilliant for, tight, unpredictable urban environments where you can't guarantee a tow truck can even park right next to a stranded car.
Exactly.
But then I look at the other side of this hardware showdown. Companies like BeCharged, they're taking a completely different approach. BeCharged is building larger solar hybrid modular systems.
Right. They are prioritizing raw capacity and energy arbitrage over ultra portability.
Energy arbitrage, that's the crucial term there. What does that actually mean in this context?
So B-charge stations are designed to store off-kick energy from the local grid when power is cheap, or they just harvest it directly from solar panels.
Oh, so they fill up when it's cheap.
Yes, exactly. They hold that stored energy in their hybrid systems and then deploy it to vehicles during the day. By shifting the energy demand across time, they're helping fleet operators cut their electricity costs by up to 35%.
Okay, that elegantly solves the peak demand utility penalty we discussed earlier. And we're seeing this BeCharge tech deployed at an incredible scale right now. I was reading the press release for EV Mobile Charge OC, and they just closed a $20 million funding round.
Yeah, $20 million is a serious investment.
Right. And they're using it to deploy a massive fleet of 42 vans across Southern California, all powered by this exact off-grid technology.
Deploying 42 vans in a sprawling, gridlocked market like Southern California is an ambitious stress test of their logistical software, honestly. I mean, they have to dispatch these vans efficiently enough to maintain their margins.
Well, they're aggressively guaranteeing sub-30-minute delivery of DC fast charging to fleets and individual drivers.
Sub 30 minutes in LA traffic, that's bold.
It is bold. They are entirely skipping the 6-figure fixed charger installation costs and just driving the power directly to the demand. And get this, they even secured the exclusive contract to provide mobile charging for the 2026 FIFA World Cup fan festivals in Los Angeles and Anaheim.
A global event like the World Cup is the ultimate proving ground for mobile power.
Oh, absolutely.
But having all these distinct types of mobile power, whether it's a AAA rescue truck, a stack of spark charge batteries, or a subscription fleet van, it creates a massive billing headache.
Right, because how do you actually charge customers for this floating energy?
Exactly. Distributing the power is an engineering challenge, but pricing floating decentralized energy is a really complex behavioral economics problem.
This raises an important question. I was looking at the strategic pricing guide from Sonic Boom, and the pricing puzzle is fascinating because EV charging curves
Hmm.
kind of make it a zero-sum game between the operator and the driver.
Mhm.
Sonic Boom breaks down three primary models. First, you have time-based pricing, where you charge the customer per minute. From the operator's perspective, this is fantastic because it forces quick turnover at the charger.
Right, but from the driver's perspective, it feels inherently unfair, sometimes even predatory,
Why is that?
because of the battery's internal chemistry. To protect the lithium-ion cells from overheating, a vehicle's onboard software deliberately slows down the charge rate as the battery gets closer to 80%.
Ah, right.
So, under a time-based model, the driver is paying the exact same per-minute rate, but they're receiving drastically less actual energy during the final 20% of the session.
Which naturally pushes the industry toward the second model, which is energy-based pricing, where you simply charge per kilowatt hour.
Yeah, that makes more sense for the driver.
The driver pays only for the exact amount of raw electricity they consume, regardless of how long it takes.
It's definitely the most transparent metric, but it introduces a severe operational vulnerability for the business.
Because drivers just hang around.
Yeah, exactly. If drivers are paying purely by the kilowatt hour, there's zero financial urgency to unplug once their vehicle slows its charge rate to a crawl. They linger, they hog the mobile hardware, destroying the operator's daily turnover and cutting into their profitability.
Wow, so it's a constant battle between perceived fairness and operational efficiency.
It really is.
And I guess that dictates the overarching billing structures too, right? Like subscriptions versus pay-as-you-go.
Absolutely.
For a KGS provider, locking a delivery fleet or a daily commuter into a monthly subscription is the ultimate goal because it gives them revenue predictability. But if a company like EV Mobile Charge OC is serving the FIFA World Cup, they have to rely on pay-as-you-go networks to capture tourists and transient drivers.
And to manage those massive spikes in transient demand, the most sophisticated operators deploy dynamic pricing algorithms.
Kind of like surge pricing.
Exactly like surge pricing. The software interfaces with the local grid and fleet demand in real time. It fluctuates the price of a mobile charge based on the time of day, localized grid strain, or the immediate density of special events.
Speaking of special events, the logistics of pop-up charging and something like a World Cup fan festival are just daunting. We have the ChemPower and EV Safe Charge source materials detailing this, and event planners cannot just run a heavy-duty extension cord into a festival field.
No, they essentially have to engineer a temporary microgrid.
Yeah, they have to audit the venue to see if 63 amp or 32 amp sockets are available, ensure compatibility with the dominant CCS fast charging standards, and figure out how to source the raw power itself.
And that sourcing is the critical variable. An event planner has to decide if they are tapping into the venue's existing substations, setting up temporary solar arrays, or, relying on heavy-duty fossil fuel generators to bridge the energy gap.
Okay, I actually want to pause on the generator point because there is a glaring, almost hilarious irony in the spec sheet for the Blink mobile charger.
I know exactly what you're going to say.
It's wild. This is a unit explicitly marketed to rescue stranded electric vehicles, right? It outputs a very respectable 7.7 kilowatts of power. But the specs clearly state this EV charger is powered by a 6.1-gallon gasoline tank.
Yeah, it's a bit counterintuitive.
You are literally pulling a ripcord on a combustion engine, burning gasoline on the side of a highway to charge a supposedly zero-emission electric car. I struggle to see the environmental logic here. It feels like a massive PR liability.
What's fascinating here is that while it seems like a total contradiction, it really highlights the pragmatism required during a massive infrastructure transition.
Pragmatism? How?
We are currently in a bridge phase. The grid just cannot universally support the required density of fixed chargers yet. A 6.1-gallon gasoline-powered mobile charger is a highly localized stopgap.
I see.
It explicitly prevents a scenario where a heavy-duty, diesel-guzzling flatbed tow truck has to be dispatched to haul a stranded EV 50 miles to the nearest fixed station.
I mean, I understand the stopgap argument. But burning gas to charge a green car still dumps localized particulate matter and emissions straight into the neighborhood you're operating in.
That's true.
And EV Safe Charge claims they offset the carbon footprint of their fossil fuel generator, used by planting trees, but come on, planting a tree 50 miles away doesn't clean the air around the generator. It feels like these companies are just holding their breath until clean, heavy-duty mobile batteries become financially viable.
Well, the industry acknowledges it's an imperfect bridging solution. The engineering reality is that scaling up pure battery storage to replace a fossil fuel generator requires an exponential increase in battery mass and cost.
Which brings us to the actual heavyweights of the industry attempting to solve that exact problem. Because even with brilliant dynamic pricing software, you cannot run a 40-vehicle commercial delivery fleet on a stack of 70-pound portable batteries.
No, the physics simply don't work.
Right. To take commercial trucking entirely off-grid, you have to look at companies like Exos Trucks. They developed the Exos Hub, which is a towable mobile charging station that weighs just under 10,000 pounds.
10,000 pounds. And moving that requires a standard heavy-duty pickup truck, but it allows Exos to house a massive internal battery capacity ranging from 210 to 630 kilowatt hours.
630 kilowatt hours on a single trailer is staggering. That is enough raw energy to power an average American home for nearly a month, and it is completely mobile.
And it utilizes CCS1 charge heads capable of outputting up to 150 kilowatts.
That's got to generate a lot of heat, right?
A tremendous amount of heat. Delivering 150 kilowatts of continuous direct current is intense. Exos had to engineer sophisticated liquid cooling systems within the hub just to safely charge up to 5 heavy-duty commercial vehicles simultaneously, completely independent of the electrical grid.
The applications for that kind of dense off-grid power are just immense. I mean, Exos recently secured a $3 million order from a leading autonomous fleet operator.
Yeah, that's a huge deal.
And they are also actively demonstrating the hub to the U.S. Air Force. The military is heavily invested in electrifying non-tactical and light reconnaissance fleets to reduce acoustic and thermal signatures.
Right, because EVs are so quiet.
Exactly. But they have to operate in austere, off-grid environments where plugging into local infrastructure is impossible.
The operational benefits are incredibly clear, but the financial reality of manufacturing a 630 kilowatt-hour mobile battery is daunting.
Yeah, mining the lithium and assembling fresh, high-density cell packs makes the initial unit cost exceptionally high.
And we can actually see that strain in the corporate financial reports for Exos. It is a brutal market right now.
It really is. In 2025, Exos saw their revenue drop by 17.81%, down to $45.99 million. When your margins are that tight, you are under immense pressure to push higher margin products like the Hub. So if a massive mobile battery like the Exos Hub or, a box power solar container is the ultimate off-grid solution, how do we make the math work? How do these companies avoid bankruptcy when the cost of raw battery materials is so prohibitively expensive?
That is the single greatest bottleneck for the entire sector. But the Atlas Public Policy Brief reveals a technological pivot that completely rewrites the financial model.
Okay, I love a good pivot. What is it?
It's the integration of second life batteries, or SLBs.
Oh, right. I was reading through the Atlas brief, and the underlying chemistry of this is fascinating.
It really is.
When an electric vehicle battery degrades over time, its internal resistance increases. It reaches a point where it can no longer safely deliver the sudden, massive surges of power required to, say, accelerate a 2-ton car onto a highway at 75 miles per hour.
Right, so it gets retired from the vehicle.
Yeah, but the brief notes that these retired batteries still retain 70 to 80% of their original energy capacity.
Exactly. The battery is no longer suitable for high-stress automotive traction, but it is an incredibly potent, slow-release energy storage device.
So what do they do with them?
Well, instead of expending massive amounts of energy to shred and recycle these lithium-ion cells immediately, companies can acquire them on the secondary market. Then they integrate them into systems like the Exos Hub or the B-Charge off-grid stations.
Wait, but you can't just wire a bunch of degraded batteries from different old cars together, right?
Why?
I imagine the engineering challenge of combining cells with different degradation curves is immense.
Oh, it is a highly complex integration. The battery management system, the BMS, has to be incredibly sophisticated.
What does the BMS actually do in this case?
It actively monitors the cell voltage and thermal output of these older batteries. If one specific cell in a second life pack starts generating too much heat due to its high internal resistance, the BMS has to instantly isolate it.
Ah, I see.
Yeah, and it balances the load across the healthier cells to prevent a thermal runaway event.
Here's where it gets really interesting. If a company can master that BMS software, The financial payoff is incredible.
The cost savings are huge.
The Atlas brief shows that buying brand new battery packs costs anywhere from $150 to $250 per kilowatt hour. But by engineering their systems to utilize second life batteries, companies drop that core component cost down to between $44 and $180 per kilowatt hour.
It effectively slashes the cost of the single most expensive component in a mobile charger by up to 75%.
He's 75%.
Yes. It drastically accelerates the return on investment for the operator and makes the massive scale of something like a 630 kilowatt hour X-Hub financially viable.
It's the realization of a true circular economy. The degraded batteries that power the very first generation of electric vehicles are literally being extracted, packed into liquid-cooled mobile trailers, and wheeled out to rescue and charge the next generation of EVs.
If we connect this to the bigger picture, when you look at the trajectory of this technology, it represents a profound structural shift. This evolution is far bigger than roadside assistance or saving a stranded commuter. It's about the systematic decoupling of transportation energy from a rigid, highly vulnerable, and increasingly expensive centralized electrical grid, making power as mobile as the vehicles themselves.
It changes how we define infrastructure entirely. Yeah. We started this deep dive looking at the paralysis of fixed charging, right? The months of trenching, the electrical panel upgrades, and the crippling peak demand utility penalties.
Which nobody wants to deal with.
Right. We unpacked how charging as a service transforms that massive capital expenditure into a streamlined operational subscription.
We covered a lot of ground.
We really did. We explored the engineering behind the hardware, from Spark Charge's modular 70-pound parallel stacks to B-Charge's off-peak solar arbitrage.
And the pricing algorithms.
Yes, the messy, gas-powered pragmatism of bridging the infrastructure gap. And finally, we saw how complex battery management systems are turning degraded second-life batteries into the financial engine of the entire mobile sector.
The sheer engineering ingenuity required to bypass the traditional power grid is forcing us to treat energy not as a fixed utility, but as a fluid, highly mobile commodity.
Which leaves you with a final thought to mull over today. If companies are already successfully deploying off-grid, solar-powered mobile chargers and autonomous fleets are already utilizing heavy-duty towable hubs, what happens when the grid of the future isn't a grid at all?
That's a fascinating question.
Just imagine a major city a decade from now. Picture a completely decentralized, constantly moving swarm of autonomous, second-life battery pods driving themselves through the streets.
That sounds like science fiction.
But the tech is almost there. They are independently soaking up excess solar power during the day, using dynamic pricing algorithms to buy and sell energy to delivery fleets and personal cars on the fly, entirely disconnected from a traditional power plant.
It really makes you rethink everything.
The tether to the garage wall isn't just being cut. The concept of the wall itself is becoming obsolete. Thank you for joining us on this deep dive. Keep questioning the infrastructure around you, keep exploring the hidden mechanics of the world, and we will catch you next time.